In this video, we're going to continue looking at hypothesis testing. The only difference here is that we are going to be looking at hypothesis testing. Ooh, that's a bit large. We're going to look at hypothesis testing with small sample sizes and unknown population standard deviations. Right, so really we've already done some similar things to this. We are just going to be doing hypothesis testing, but with the t-stat. Right, our student's t-distribution was introduced in the last chapter, and really that's the big difference. We're not going to go through all of the different steps that we would normally go through when as we did in the other videos. Instead, we're just going to look at what is different, right? And it's not much, right? The only things that are different are the test statistic and the critical value, right? So with our critical value, if we are doing a two-tailed test, this is going to be T alpha divided by 2, and with our degrees of freedom, right? And those degrees of freedom equal n minus 1. So just like when we were using the t-distribution in the previous chapter. If we are doing a one-tailed test, then we will be looking for T alpha and then our degrees of freedom, right? And then of course, if it's a left-tailed test, that it needs to be negative. If it's a right-tailed, you would keep it positive. Right? So that's the only difference. They're really just basically saying for the critical value, we're just going from using Z to using T. Then for the test statistic, right? So previously it was the Z stat. Now we're going to be calling it the T stat because we are using the T distribution. It's going to look pretty much the same as it did before, right? The only real difference in the way we're writing it out is that instead of having sigma, we have S, right? Other than that, it's functionally exactly the same. There is no difference between this formula and the one we were using for the Z stat, right? And that's it. That's the only differences between this and what we've been doing previously. Well, I forgot what I was going to say though. So we're not going to go through all of the different, all the other steps are the same, right? We're going to write out and list our hypotheses exactly the same as we did previously, and then we're going to reach our conclusions like we did as well, right? For a two-tailed test, if our test statistic falls in between our critical values, we fail to reject the null hypothesis, so on and so forth, right? But those rules and such, we have listed down. All right, so what we're going to do now is we will go over an example of this kind of hypothesis testing. All right, so let's say, and this is going to be a rather silly example, as most of mine are, I suppose. So let's say that we are looking at the number of pages in a book, right? And we think that the number of pages, and I'm going to be doing shorthand for most of this. So let's say we're looking at we've got a bookcase. We want to know, or I guess a shelf based on my sample size I've already written down. And it's got some books on it. We want to know, we want to say something about the average number of pages in those books, right? Or in books based off of one shelf, we could say. All right. So we think that the average number of pages for these books is less than 200. Right? So that's what we are assuming to be true, right? Or that is what we are wanting to find out, right? So we want to know right? Are there less than 200 pages on average in these books, right? And so we go and we grab 17 books off of our bookshelf, and we look and see how many pages there are, and we come up with an average of 176.291 with a standard deviation of 151.728. Right, and we want to perform a hypothesis test at the 1% level. Right, so we would start. Our first step, of course, is setting up our null and alternative hypotheses. So our null hypothesis and our alternative, again, usually the alternative is a bit easier to figure out, right? We are claiming that the average number of pages in a book is less than 200. So that is our claim. That's our that's our alternative hypothesis. Mu less than 200. All right. So now that we've got that alternative hypothesis, we just need to make the null hypothesis the opposite. So if our alternative is mu less than 200, our null has to be mu greater than or equal to 200. All right, then we would need to specify our alpha, all right, specify our significance level. That's been done for us up here. We're doing it at the 1% significance level. So then we can move on to the next step of finding our test statistic. Excuse me, that's not what we're going to do. We're going to find our critical value. So T, all right, when you got to now say, is it alpha or alpha divided by 2? Well, we're doing a left-tailed test, all right? It's a one-tailed test, so it's just alpha. We're not going to divide that by 2. We actually know our alpha, so we can actually write that down. All right, so our alpha is 1%. And then we need our degrees of freedom, and our degrees of freedom are 16. So, I wrote the wrong one down in my notes, so we're going to have to go look real quick. Alright, so 2.583 is our critical value, right? But this isn't the actual critical value that we're going to need, because we have to remember that we are doing a left-tailed test, so our critical value needs to be negative. All right, so we need to make sure we make that negative for it to be our correct critical value. Now, if we want to use our little distribution, right, the little visualization of this, which I think is often a good idea, then we can go ahead and draw that out now that we've got our critical value. And so we can set up our rejection region, right? So if the test statistic that we're about to calculate falls into this region, this red region, then we're going to reject the null hypothesis. If it falls on the other side, we are going to fail to reject the null hypothesis. All right, so we're going to calculate our test statistic using this new formula, although it's really pretty much the same formula. So we're going to take our x bar, so that's 176.291. We're going to subtract our hypothesized mean, or our C, our arbitrary constant, which is 200. And then we're going to divide that by our standard deviation, 151.728, divided by the square root of our sample size, which is 17. All right, so once we enter all of that into our calculators, we're going to get negative 0.644. Right, and then we could go and see, well, where does that fall? One, we could just compare our test statistic and our critical value, or we could take these up to our chart. And I kind of forgot to put something, that's okay. Well, no, I do want to add that. All right, so we'd have 0 here because it is the center of the chart. But we would have, right, negative 0.644, right, that falls to the right of our critical value. So that would mean that we would fail to reject the null hypothesis. All right, so we didn't fall into that rejection region, so we don't have enough evidence to say that the average number of books, the true average, is less than 200. All right, so let's clear this off, and then I'm actually going to write that conclusion down. All right, so our conclusion, all right, we would fail to reject the null hypothesis. And really, when we fail to reject, that's all we really need to say. If you're just asked for a conclusion, what's the conclusion? We failed to reject the null hypothesis. If you're asked for something more, like, what does that suggest? Right? It doesn't prove anything, but it might suggest some things. But we can say, all right, if we want to further that, there is no evidence that the average number of pages in a book is less than 200. Right. Again, we cannot say anything conclusive, right? Failing to reject, that's it's not a very strong statement. That's why we would rather have a rejection, right? Or we want to set up our hypothesis test so that our claim can possibly get a rejection, right? Because that is a stronger statement. All right. But again, that's it for hypothesis testing with the t-statistic. Again, really, it's just substituting those critical values. All right, that's really all it is when you get down to it, so we don't really. So it's still kind of the same stuff. All right. In the next video, we're going to look at the difference between practical and statistical significance. All right, I will see you then.